Example 5, we've got another graphing one, graph the hyperbola and also the foci, and use asymptotes to help graph. So let's figure out the center of this thing. And the center is going to be, if we look at the x term, we've got a 1, and then the y term would be a 2. Remember to just do the opposite, and I always look for the x term first. Might be over here, or it might be on the right side. Just depends on whether the graph will open left and right. Definitely going to be a hyperbola. We got a minus sign. Each one of these is squared. Next, we need to find a, b, and c, or you can also plot. I guess let's plot 1, 2. That's the center. So a will be the square root of whatever's underneath the first term. That's square root of 9 or 3. And then b is just the square root in this case of 16 or 4. To find c, we've got the square root of 9 plus 16. Add a squared and b squared. And that's just going to be 5. The next thing is to plot our vertices. So if we take a look at the vertices, this graph goes left and right, opens left and right. So we're going to go from the center, we're going to go right 3, and we're going to go left 3. So that would be 1, 2, 3, or right here. So you can see that we've got a distance of 3 between the center and each one of these vertices. Actually, the foci are going to be right here and here. And if you're wondering where to start at, sometimes I confuse myself just a little bit, but I always go from the inside point here because the foci will be further away from the center than each one of the vertices. To graph this accurately though, we really should be drawing some asymptotes. We also need to find the actual foci. So I tell you what, let's find the actual foci. We're going to use asymptotes to help us graph. So if we take a look at the foci here, we got to start at our center. We're going to go left and right by the same amount, and that's c. So we're going to change the x coordinate. So we're going to do 1 plus 5, which is 6, comma 2, and then 1 minus 5, which is negative 4, and then the y value will stay the same. So there's our foci. We've already plotted them. Looks like we're good to go. Let's do the asymptotes, and instead of actually writing the equations for the asymptotes, which you definitely could and should be able to do, if you're just asked to graph, I like to just use b here, which is 4, and I go right to each one of my vertices and I go 1, 2, 3, 4, down 4 and up 4. So it's going to be 1, 2, 3, 4, and then from the other vertice as well, 1, 2, 3, 4. So we've got a point there and down 1, 2, 3, 4. And all this is doing for us is it's just making that box, and if you connect the corners of the box through the center, then that'll give you your asymptotes. Try to extend this guy a little bit here. There we go. Extend it as far as you need, should be to the graph at least. So we've got the other asymptote to the edges of the graph is what I mean to say. So those are the asymptotes. Whether you do it dashed or just lightly, that's fine. A little bit hard to do here with the markers, but we'll go with the flow. And then all we need to do is take each one of these vertices right here, and we're going to try to draw a nice curve shape, and that curve shape has to get close to but not cross each one of the asymptotes. And so this shape is going to look something like this. And that's it, really. We've got the hyperbola, we've got the foci, and we used asymptotes to help us graph.